Welcome to this presentation. I'm Emiliano and today we will talk about UML Class Diagram. So what is it? A class diagram is a static diagram. It represents the static view of an application. Class diagram is not only used for visualizing, describing, and documenting different aspects of the system, but also for constructing executable code of the software application. Class diagram describes the attributes and operations of a class and also the constraint imposed on the system. The class diagrams are widely used in the modeling of object-oriented systems because they are the only UML diagrams which can be mapped directly with object-oriented languages. A class diagram shows a collection of classes, interfaces, associations, collaborations, and constraints. It is also known as structural diagram. So, what is the purpose of the class diagram? The purpose of class diagram is to model the static view of an application. Class diagrams are the only diagrams which can be directly mapped with object-oriented languages, as I say before, and widely used at the time of construction. Now let's talk about pros and cons of the UML class diagram. First, most used and flexible. UML is a highly recognized and understood platform for software design. It is a standard notation among software developers. You can safely assume that most software professionals will be at least acquainted with, if not well revised in, UML diagrams, thus making it the go-to alternative to explain software to design models. The second pro is software architecture must be communicated effectively. The software architecture is the blueprint of the system. It is the framework on which the efficiency of the system and its process depend. But this framework is only effective if it is communicated properly to all those using it and working on it. This is where unified modeling language UML comes into the picture. Another pro is you need to know only a fraction of the language to use it. Though there are 14 different types of UML diagram for modeling applications, developers use only 3 or 4 to document a software system. Class diagrams, sequence diagrams, and use case diagrams remain the most in vogue. Abundance of UML tools. UML tools are one of the most important reasons why UML is so widely used. UML tools range from free open source software to those costing millions of dollars. Now let's talk about the cons. Formal notation is not necessary. The stronger argument against UML is that you don't really need a UML diagram to communicate your designs. You can have the same impact and effect with informal box and line diagrams created in PowerPoint, Visio, or Whiteboard. As coding is a formal language by itself, a lot of developers don't prefer the complexity and the formality at the architectural level, which discourage the use of UML and has become one of its disadvantages. Then we got ascending degree of complexity. Since its initiation until now, UML has grown in complexity and size. Then we got another con, which is non-necessary in architecture indifferent design. That term is coined by George Fairbanks. There is a situation where UML is considered unnecessary. At its core, an architecture indifferent design refers to a software architecture that is simple and basic and does not need to have a complex diagram to represent or explain the design.
Thanks, Emiliano, for introducing UML class diagram. What I'm going to do, I'm going to describe the elements of the UML class diagram. Then I'll go into how we can use this with the HeyFit application. And then I'll finish this with the recommendation that we have. So the first thing you'll notice in the UML diagram is that there are several different boxes. Each box is a separate class. So the name of the class appears in the first partition. So for this example, the name of this class would be shape. The class attributes are shown in the second partition. The attribute type is shown after the colon. As you can see here on the right side, attribute maps onto member variables in code. Okay, the third partition is operations. They are services the class provides. The return type of a method is shown after the colon at the end of the method's signature. The return type of method parameters are shown after the colon following the parameter name. Operations map onto class methods in code. Now, another part of a UML class diagram is a class visibility. You'll see right here to the very left of the attribute up there, there's a plus, a minus, and a pound sign. So the plus sign, it denotes public attributes or operations. The minus or the dash, it denotes private attributes or operations. And the pound sign, that denotes protected attributes or operations. So what are relationships between the classes? Now, this may seem as a review from the reading that we did earlier in the week, but we'll just quickly go over it. So associations are relationships between classes in a UML class diagram. They are represented by a solid line between classes. Associations are typically named using a verb or verb phrase, which reflects the real world problem domain. Inheritance. A generalization is a taxonomic relationship between a more general classifier and a more specific classifier. Each instance of the specific classifier is also an indirect instance of the general classifier. The specific classifier inherits the features of the more general classifier. This also represents an is-a relationship. Realization. Realization is a relationship between the blueprint class and the object containing its respective implementation level details. This object is said to realize the blueprint class. In other words, you can understand this as a relationship between the interface and the implementing class. Dependency. Dependency, an object of one class might use an object of another class in the code of a method. It's a special type of association. It exists between two classes if changes to the definition of one may cause changes to the other. And also class 1 depends on class 2. Aggregation, it's another special type of association. It represents a part of relationship. Class 2 is part of class 1. Many instances of class 2 can be associated with class 1. Objects of class 1 and class 2 have separate lifetimes. The final is a composition, a special type of aggregation where parts are destroyed and the whole is destroyed. Objects of class 2 live and die with class 1. Class 2 cannot stand by itself. Okay, so how can we implement this, the UML class diagram with the HeyFit app? Right here, I created a very simple UML class diagram. As you can see, I took each of the classes that we as a class came up with for this application, and I I made the necessary I made the necessary relationships between each of the classes. As you can see, there's a few associations. We have an inheritance class and also dependency. But as you can kind of see, using a UML class diagram, it's very simple, it's effective, and it makes things just look really nice. So here's a recommendation. So you should use a UML class diagram when you're object-oriented programming. That was talked about, Emiliano talked about that previously. When you should show, so when you want to show classes, interfaces, associations, collaborations, constraints, that's when you want to use a UML class diagram. And then another great thing about class diagrams is it represents the static view of an application. Thanks for watching.